Hi guys, today we're going to talk about loans and investments. This is part of section 1.5 in chapter 1. You received a handout for this earlier today. If you did not receive it, please see me as soon as you can tomorrow. So a loan is basically something where you have to borrow the money and pay it back, so that's usually a bad thing. Unless you're the bank, an investment is when you put money into the bank and you earn more money, so that's a good thing. You notice the two main differences between the loan and investment formulas would be right here, this minus sign in the loan formula, whereas over here we have a plus sign in the investment formula. With a loan, you have this large sum of money that you're trying to chip away at. You eventually want it to disappear, disappear, disappear by making payments towards it. An investment, on the other hand, starts small, and you want it to grow bigger and bigger by adding more and more money into it each year. And while you're putting more money in, the bank is actually compounding that amount by giving you what's called interest. In a loan, the interest is actually a bad thing for you because it's like charging you a fee in order to borrow the money. In any event, the interest rate will come into this formula right here in the numerator on both sides. That's where the rate will go. If the rate was 5%, you would put 0.05 up there. If the rate was 8%, you would put 0.08. The other part of this formula involving the rate would be the number of times that the interest is compounded each year. And that will come into play in the denominator right there. If it's monthly compounding, you'll divide the rate by 12. If it's weekly compounding, you would divide the rate by 52. With daily compounding, which is pretty rare, you would divide the rate by 365. Again, so let's just recap. The way this recursive formula will work, whether it's a loan or investment, will be here will be the initial amount that you borrowed. Here will be the initial amount that you invested. In the numerator in red, you're going to have the interest rate. In the numerator in green, you'll have the interest rate. In the denominator, you're going to have the number of times compounded per year. Quarterly would be 4, monthly again would be 12, etc. And then finally, this second part of the recursive formula will be your payment that you make monthly or weekly. And then on the green side, it would be the initial additional amount that you'll put into the bank, weekly or monthly. So let's see how that works when we go over here to the second page and talk about this investigation. Actually, let's come back to the investigation in another video. Let's jump all the way over to this example with Gwen's employer right here. This example says Gwen's employer offers an investment plan that invests a portion of each paycheck before taxes are deducted. Gwen gets paid every week. The plan has a fixed annual interest rate of 4.75, so that tells us that the rate is 0.0475. Again, so we are converting the rate from a percent to a decimal, 0.0475. Get off the magic pen there and onto a regular pen. So it says it's compounded weekly. Now we're going to call that, we're just going to remember that that denominator and that fraction from our formula is going to be 12. Let's call that n, which indicates the number of times compounded. So that's going to be 12. 12 times per year. Oh, actually 52. I just realized it said weekly and not monthly. So that n is going to be 52. She decides to contribute $10 each week. What will her balance be in 5 years? Now that's going to be a long time. That's going to be a lot of weeks. If you think about that, that's 52 times a year for 5 years. So we're going to learn a new technique on the calculator today that's going to involve a sequence form. We're going to go to our calculators now, so please take out your calculator, and let's go to something called sequence mode on the calculator. So this is kind of neat here. If you take a look at this, turn your calculator on and press mode. And what you might notice about your calculator is that it has a couple modes in the fourth line down. One is function, one is PAR, that stands for parametric, the other is POL, that stands for polar, and the fourth one that you see there is sequence mode. So let's scroll down to the fourth line and over to sequence mode. I got here by pressing the mode button, and let's press enter. That puts sequence mode on. When you go to y equals now, what you might notice is your normal y equals screen, where you would input lines and parabolas, now looks pretty weird. It says it wants you to establish what n min is, and I'm going to put that at 0. It wants you to tell it a formula to use for u sub n. This looks a lot like what we've been talking about in class. Then it wants you to establish what u n min is. So if you think about that, 0 is n min. So what it's asking us here is, what is u0? And it says here that Gwen really didn't put any money in to start. So she's actually starting with $0 as her minimum. She's going to put in $10 more a week, but it's going to take some time to build up. So if you need to pause and rewind at any time, that's the beauty of the video if I'm going too fast. So the next portion is we want to now tell it the formula that we want it to use. So what we want to do is we want to go back and think about the formula from a couple slides ago where it said 1 plus the interest rate, which is 0.0475, double check that, yep, 0.0475, divided by the number of times compounded per year, and that would be 52. So we're multiplying the previous amount times this rate. So it's 1 plus 0.0475 divided by 52. We want to multiply this, so times the previous term. Now in class, we learned that to be u sub n minus 1. It's the same thing on the calculator. The u is actually found when you hit second, 7. You see the u pop up? We enter n minus 1 by putting parentheses. The normal button that you would use for x now serves as the n key because we're in sequence mode. So we're going to press that button, which is right above the apps button, minus 1, close. We just told it to take our rate divided by 52 plus 1 times the previous term. Now, don't forget, Gwen is actually going to add 10 extra dollars into her account each week. So we're going to hit enter, and now our formula, our starting amount of 0, is now in the calculator, and we're actually ready to go. What we can do, you can graph these, but the power, the beauty of this really comes from looking at a table. So let's go to second table, which is above graph, and it shows you here as n goes up by 1, that's 1 week, 2 weeks, 3 weeks, 4 weeks, it's showing you how much money Gwen has in her account each week. $10, $20, $30.03, $40.06, etc. Now, we would have to scroll down pretty far to get to 5 years because that's over, let's see, 52 weeks times 5 years. That's a long time. It's like 200, what is it, 260 weeks. So we could scroll down to 260 weeks. Or what you can do with your table is you can actually go to second table set. That's above window. So second window. That takes you into the table setup screen. And if you go down to independent, hope you're following here. If not, again, pause, take a breath, rewind, check it out again. We're going to go down to independent and go right and put it on X. Now watch what happens when you go to second graph. When you go back to the table, it's gone. It's blank. That's because it's now waiting for us to input the number of weeks. How much money would Gwen have to have after 1 week? Enter, $10. 2 weeks? Enter, $20. Now we can jump all the way down to 52 times 5, which would be 52 weeks, times 5 years. That's 260 weeks. And it's thinking about it. You can see, voila, it gives us our answer. $2,933. If you want the exact change, put your cursor right over top of it, and it'll tell you that it's $2,933.21. $2,933.21. 2,933.21. 21. That's how much Gwen would have in her investment just by putting away $10 per week for 5 years.